Story-driven games are actually very easy to make. And that's exactly why the code turns bad. When gameplay changes because of dialogues, cutscenes, or events that happen in the game, most projects end up with logic scattered everywhere or logic concentrated into a single place. In this video, I'll show a simple way to structure code for story-driven games. I'll teach you the core concept first on Krita and then we'll move on to the code. This isn't the only way to do it, but it's a clean way that scales as your game grows. Typically, this is how a story-driven game is usually worked out. We have different systems, dialogue, cutscene, and level, and they're all dependent on the player controller. As the game grows, this player controller or the game manager will have a lot of responsibilities to handle, and it is a very bad way to do code. And the way we solve this is by introducing an in-between authority class, which will observe different facts or things happening in our game, like cutscenes and dialogues, and will interpret different states in our game, and other classes will be able to execute based on the different states interpreted by this authority. In sandbox games, if you look at the right, we have a bunch of different systems. So it is easier to code. But in the case of story games, there's a linearity in the way things are executed. Therefore, we introduce a game authority class, this one here, and everything else like player, NPCs, and everything will be dependent on this authority class. Okay? Before we touch code, I want to explain the system. We have three different things: fact, interpretation, and execution. A fact simply means something has happened in the game. For example, a cutscene has ended, or a dialogue has been reached, or a level has been loaded. The fact communicates with the interpretation, and this decides different states. For example, it checks whether the player is in exploration mode, or if the combat is restricted, or if the player is injured. The execution relies on the interpretation. Okay, so there's no linear flow. Everything is directly coupled to the interpretation part. The interpretation part doesn't do anything. It just interprets based on the facts that they receive. So again, this is how it goes. We have different events, and this reports to the authority of various facts, and then the authority interprets different states and rules. And these states and rules could be simple enums. And then different executions, like different systems in our game, checks for the current state in the game authority and then performs the code. So facts, interpretation, execution. Okay? In a sandbox game, however, the authority is a separate thing outside of the systems. It's not a part of the core mechanic of the sandbox game. In sandbox games, systems communicate directly or indirectly with one another. So let's look into how we can perform the code. Here I have a very simple example. I have a player, I also have a game authority, and a conversation trigger. Let's assume this Unity ball is a character that we want to talk with. First, let's look at different facts in the game. I have created a simple enum called gameFact, which just reports two facts. It reports whether the player is in free movement or the player is in conversation. Okay, this is a simple enum. We've also created another enum for a game state, and this is the state of the player. So the player is free or the player is in conversation. Facts report stuff. The state is being set based on the facts. Okay, if the player is in free movement, then we set it to free. Okay, in a bigger game, you'll have multiple different types of game states and multiple different types of game facts, which is why there are two separate enums. Okay. Now we have a game state authority class, which contains a serialized game state called current state, and that is set to game state.free. So the player starts in free mode. We also have a list of game facts called pending facts. Okay. So whenever we are creating a mechanic, in this case, we need to have a conversation with this character here. And to do that, we need something that reports facts. In this case, we have a conversation trigger. And I've also created a conversation trigger script, okay, which has a reference to this game state authority. And at start, we find the game state authority by using the find first object by type. Very straightforward. And on trigger enter, if it hasn't interacted previously and the other game object has a tag called player, we firstly set the other game object's position to be transformed at position. So we teleport the player and we say game state authority dot report fact, and we provide an enum called game fact dot player is in conversation. So we report the fact that the player is in conversation to the game state authority. Now we have a report fact function which takes in a game fact. Now, if the pending facts doesn't contain the fact that it is in a conversation, just add that fact. Okay. So this list now contains the fact that the player is in a conversation. Now inside update, this is where we interpret facts. If there are no pending facts, we just simply return, meaning this update will only run when there is a pending fact. So this line of code will happen only once. So for each var fact in pending facts, we just apply the rules to that fact, which is a custom function down below. But afterwards, we say pending facts.clear, meaning if it is 0, we return. When something is added, it will become 1. Now it will apply the rules and then immediately clear the list. So there is no more pending facts remaining. That fact has been interpreted. Okay? So this line of code will only happen once. Now we're confirming that, which is why it is safe to put it inside update. It only checks a simple if condition. Now this apply rules is where we actually set different states. And now if the current state is free, meaning the player is actually free, and we've been reported that the player is in conversation, we set the current state to game state.conversation, and then we can just debug.log. Else if the current state is in conversation and we've been reported that the player is in free movement now, we set the current state to game state.free. Like I said, interpretation just sets the current state. It doesn't do anything. What actually does the logic is the different systems in the game, the execution part. In this case, I have a player movement system, which also has a reference to the game state authority and contains simple code to move. Firstly, it finds the game state authority if it is not assigned in the Unity editor. And then inside update, before we do the code to move, this can also be used inside events, by the way, we perform a simple if condition check. We check if not game state authority dot can move. So we are checking for game state authority and we are asking for its permission. Hey, can I move? If I can't move, I just simply return out of it. And this movement system does nothing. So the game state authority contains these permission queries. Public bool can move, and that will only return if the current state is free. Also, another query, we check if the player is in conversation, and we just return if the current state is game state.conversation. I also have a script called conversation handler. This is another system which will contain a reference to the authority, and it does continue the conversation. It first gets the authority at start, and then inside update, we use this permission query. If the game state authority has set the state to be not in conversation, then we just return out of this. But if it is in conversation, the conversation handling logic goes here. In this simple case, I've said if attack action is triggered, left click in this case, we report the fact that the player is in movement. But in the conversation trigger, when we enter the trigger, we report the fact that the player is in conversation. So these are triggers. Triggers report facts, while the systems, which can also contain triggers in itself, will use these permission queries. Okay? If this were a normal game manager, all of these things will be done inside the manager. In this case, this only sets the current state. It does nothing else. Okay? So this is not a technical manager in the sense, but it does the same exact mechanic, but there is lack of coupling between the triggers and the executors. Does that make sense? Now let's test and see if it works. If I move, you can see that the player teleports and the game state has been changed to conversation. Because we're in conversation mode, the movement does not work because we cannot move, because the authority has decided that we can only move if the current state is free. So now, even though I'm pressing WSD, it is not moving. But if I press the attack key, based on the conversation handler, if the attack action is triggered, we report the fact that the player is back in free movement. So if I click, now the player is back in free movement and the conversation has been over. So this is how story-driven games should be made. We need a central authority that does not become a manager. This just interprets different facts that have been reported to it and then sets the current game state. That is all. And all of the execution part, all of the movement code, the combat code, inventory, whatever that you actually have to do, has a reference to this authority and then does its logic only if it is allowed to do so. This is how story-driven games can be made with clean code. Okay, you can make it with the normal managers and stuff like that. It's perfectly fine. But this is the way that I recommend you to start doing, because this is cleaner in the long term. Whenever you need to add a new mechanic, add a new game state, and then interpret a different state. It's very simple code, okay? And you're going to have a lot of fun with this way of writing code. That is all. The main idea that I want you to take away is this: story logic should have authority, and gameplay systems should ask for permission. That's it. Once you decide who decides things and who executes things, story driven games will stop feeling messy. And it gets predictable the more you practice this. You're not going to get this in the first time exactly right, but the more you practice this way of coding, then it's going to get better. If this way of thinking helped you, you can adapt it in your own projects. Let me know what video you're interested in next. Thanks for watching. And as always, take care. See ya. Bye bye. I love you.